So in this module, we're going to take a closer look at environmental economics. So we kind of just discussed this idea of positive and negative externalities and how the consumption or production of some goods cause an effect on other people. And now we're going to take a closer look in particular about pollution and different ways that we might seek to limit the amount of pollution we see in our society. So let's begin by giving kind of a quick rationale behind why we might want to regulate pollution. A rationale of regulating pollution. Regulating pollution. So in the production of a lot of goods generates pollution. You know, when we produce a lot of different goods, we kind of get some pollution as a byproduct of this production. And this is going to impact other people, other members of society. So the production of most goods generates pollution. That influences other people, that influences other members of society. Not supposed to say other there. Other members of society. And we're going to think this has a negative effect on other members of society. So it's going to think about it as being a negative externality. And this kind of means that the marginal cost for the private firm is going to be is going to be less than, let's just start that all over again, that the marginal cost for the private firm is going to be less than the marginal cost for society, because we have this external cost, which is making that society's cost of the production of this good greater than the firm's private cost of production. And so let's quickly erase this and kind of draw a graph of why this is going to result in the overproduction of different goods in our society, because we're not going to account for the fact that, or these firms are going to be self-serving, and they're not going to account for the fact that the production of their good causes a negative effect on other people. So let's quickly review kind of our graph for this negative externality. So here's our Cartesian plane. We're going to have price or marginal cost here on the y-axis, and we're going to have the quantity produced on the x. So we have a downward sloping demand curve, which we're going to think is the marginal benefit curve. We have an upward sloping marginal cost curve, and let's say this is the private marginal cost. And so kind of left on its own devices, or to its own devices, we're going to get this much produced by the competitive market. But if there's an externality, there's an external cost to the production of this good. And so the marginal cost for society, or MCS, is just this marginal cost for the private firm plus this external cost. And so if we account for this external cost, we see that the actual optimal amount for society for the production of this good, whatever good we're looking at, is Q star, right? So we're overproducing. And so what our goal here is to get firms to internalize this externality. We're trying to come up with efficient ways so that firms, instead of producing QC or seeing QC exchange in the market, we actually see this Q star. So we're trying to figure out ways to get us here. And ideally, we want to find a way that's the most efficient way of getting us there. So let's just kind of write out what I meant there. If externalities can be internalized, allocatively efficient production can be achieved. Allocatively efficient production, levels can be achieved. Oops, achieved. So we want to push us from QC down to Q star. So really in this module, we're talking about different ways to push us from this QC to this Q star. All right, so let's talk about the optimal level of pollution abatement. So abatement is like reduction. So the optimal level that we should be reducing pollution by. Optimal pollution abatement. So normally it's not going to be optimal to reduce pollution by 100%. And so let's kind of draw a quick graph and talk about the optimal level of pollution reduction or abatement. All right, so on this x-axis is going to be pollution abatement. And it's going to cap out at 100%, right? That's the most we can reduce is kind of 100% of the pollution that we'd see or that we would produce. On this axis, we're going to have the price or the dollars per unit. That's how we're going to measure. And then we can start to think about what curves might look like. So let's think of the marginal benefit, so the benefit of reducing pollution by a little bit. Well, when we're not reducing any pollution, so if this was 0 amount of pollution reduced, eliminating that first little bit of pollution, maybe reducing the smog a little bit, is going to have huge benefits to society, right? Large health benefits and things like that from reducing the first little bit. But as we reduce more and more pollution, we're going to see diminishing returns to this reduction in pollution. So our marginal benefit curve of reducing pollution, I have to go back to another color here, might look something like this. So we're going to think of this as the marginal benefit of pollution abatement. Now let's look at the other side, the cost of reducing pollution. Well, eliminating that first little bit of pollution might be fairly inexpensive. We can, instead of just pumping things directly into the lake, we can start to filter things. We can do all sorts of things that are not going to be costly, but they could have huge effects, right? Could have huge benefits, but they're not that costly. And so I don't have another color here, so I'll have to go back to pink. And it's likely that the costs are getting bigger and bigger as we, the cost of reducing that first little bit of pollution is relatively cheap, but as we reduce more and more pollution, it's harder and harder to find ways to reduce the pollution. It's more and more expensive. This is going to be like our marginal cost of abatement. So notice that our optimal amount, we should be reducing pollution until the reduce pollution, or by that I mean abate pollution, until marginal cost of abatement equals the marginal benefit. Maybe I'll just say marginal benefit of abatement. So that would give us the optimal amount of pollution that we should reduce. So here's this Q star. And so it's going to be not 100%, so that means we're not going to reduce pollution by 100%. Usually it's not going to be optimal to do that based on the costs and the benefits of reducing it. And so what we want to think about is ways to reduce pollution by this optimal amount in the best possible way, in the most efficient possible way. And so we're going to talk about 3 different ways that we might try to regulate or change pollution or control pollution. The first is going to be just like a direct control. The second is going to be through pollution, taxation. And the third is going to be through a cap and trade system. And in particular, we're going to talk about how the latter of the two, the pollution taxes and the cap and trade, are going to be more efficient than these direct controls. So let's take a look at these 3 different methods for controlling pollution.